Okay, so today we're going to talk about how to multiply numbers when they have decimals in it. Now, if you'll remember at the beginning of the year, we talked about how to multiply numbers that had multi-digits, and you've been doing this since fourth grade. You had a couple of different strategies. Some of you used the algorithm, some of you used the area model where you drew your boxes, but we have never done it before when we had decimals in the numbers. So we're going to talk about that today. So the first one I'm going to do with you, and this one we have 2 and 91/100ths, and we're multiplying it by 3 and 2/10. And in this case, the first thing you're going to want to do is you're going to want to estimate what your answer will be. You're dealing with a decimal, which, as we know, everything to the right of the decimal is a part of a whole. So we want to round it to the nearest whole number. In this case, we have 2 and 91/100ths. So that's closest to what whole number? Well, hopefully you said 3, because we would round it to 3, not to 2. This is 2 and 91/100ths. It's like $2.91. You almost have $3. And in this one, we have 3 and 2/10. So what whole number would we round 3 and 2/10 to? Well, it's closer to 3 than it is to 4. So we round both of these actually to 3. Well, what's 3 times 3? Of course, you know it's 9. So we know our answer is not going to be exactly 9, but it's going to be pretty close to 9. So the first step we do is we estimate what our answer is going to be. All right, after we do that, we're going to count the digits that are after the decimals. So the digits that are to the right of the decimal. In this case, we have 1, 2, 3 digits that are to the right of the decimal. So we need to remember that for later. So I'm going to put down over here, we have 3 digits to the right of the decimal. Now come in later. And after you do that, you are simply going to solve it, pretending that the decimals are not there. So I'm going to erase them for a second, and we're just going to pretend that we are multiplying 291 times 32, which you already know how to do. Some of you use the area model, which I've already done, which is right here, where you expand out 291 to 200 plus 90 plus 1, and you multiply that by 32, which is 30 plus 2. You take the 3 zeros here and you put them in this box. 3 times 2 is 6, so that becomes 6,000. You have 2 zeros between 90 and 30, and that becomes 2 zeros there. 9 times 3 is 27, and on and on. And you went and then you added up all these numbers. I'm not going to go into this in detail just because you guys already know how to use the area model. But you ended up with 9,312. Some of you use the algorithm, which I'll go over here. You have the 2 times 1, carry the 1, it's 5, got to put my 0 here. 3 times 1 is 3, so it's 27. 8. Got to add these two together. I'm going to do it down here because I've run out of space. And we get the same answer, 9,312. I'm going to leave that comma out because we have to think. Now remember when we estimated? Back when we estimated, we said that our answer should be close to 9. So we need to put the decimal back in. Where would it make most sense to put the decimal? Would it make most sense to put the decimal before the 9? After the 9? So that it would be 9 and 312 thousandths? That sounds pretty good. Or would it make sense to put the decimal after the 3, where it's 93 and 12 hundredths? That would make sense. 93 isn't close to 9. What if we put it here, where it was 931 and 2/10? That is nowhere close to 9. If we put it here, it'd be 9,312. That's not true. So the one that makes the most sense is to put it right here, in between the 9 and the 3. So our answer would be 9 and 312 thousandths. Now let's remember when we counted, put those decimals back in. Remember we counted and we said there was 1, 2, 3 spaces after the decimal? Wrote that down here. Well, you always want to make sure your answer ends with 3 spaces, 3 digits after the decimal. And so we got that, 9 and 312 thousandths. And you can see you had 2 ways to check it. One was your estimation and one was counting the places after the decimal. Okay, so that was the one that we did, that I did for you. This next one is going to be the one that we're going to do together. So make sure, look at your paper and make sure you find this one on your paper that has this one, because we're going to do it together. So what's the first step? Do you guys remember? Let's estimate. I'm going to bring this back in case you forgot. It's estimate. I'm sure you can see. It's estimate. We want to estimate. We have 25 and 3/10. What whole number is that closest to? Well, hopefully you saw that that is closest to 25, right? So it's about 25. Now we have 1 and 8/10. What whole number is that closest to? Is it closest to 1 or is it closest to 2? Well, hopefully you see that that is closest to 2. So really what we have is 25 times 2. What is 25 times 2? You're right, it's 50. So we know our answer is not going to be exactly 50, but it's going to be pretty close to that. Our second step, if you'll remember, is to count the digits after the decimals. So let's go ahead and do that. We have 1 and we have 2. So I'm going to write that down. I want to remember that I have 2 spaces, 2 digits that have to go after that decimal when I'm finished. Step 3, if you'll remember, is to solve without the decimals. We're going to pretend like those decimals are not there. Let's just go ahead and take them out. And let's solve it without the decimals. Some of you are going to use the area model, and you can go ahead and use that now. I'm going to show with the algorithm and then come down and do the area model, and we should get the same answer. 8 times 3 is 24. Carry the 2. 8 times 5 is 40, plus 2 more. Oops. My eraser. 40 plus 2, 42. 8 times 2 is 16, plus 4 more is 20. What do I do when I go down to my second line? I've got to put a 0, because I'm not multiplying by 1, I'm multiplying by 10. 1 times 3 is 3. 1 times 5 is 5. 1 times 2 is 2. And I'm going to get my answer by adding this. This is 4, this is 5, this is 5, and this is 4. So I have these numbers, 4, 5, 5, 4. And I know I have to get an answer that's close to 20. Oh, excuse me. That's close to 50. In this case, where could I put my decimal that would make it about 50? Well, if you're stuck and you can't see it, we can use this. Remember, how many digits have to be after the decimal? 2. So if we put it right here, it would be 2 digits after the decimal. 1, 2. This is 45 and 54 hundredths. Is that close to 50? 45 is pretty close to 50, isn't it? So we know our answer makes sense. If we put it here, we'd have 4 and something. That does not make sense. If we put it here, it would be 455. That is not close to 50. Okay, so filling in here, we'd have 3 zeros and a 2, 2 zeros and a 5, 1 0 and a 3. We'd have 2 zeros and 16, 1 0 and a 40, and then 24. each one up, we would get 2,500 plus 30. Down here, we'd have 1,600 plus 424. And we get the same answer here, and we put our decimal right here. So now it's time for you to try one. Go ahead and write this down and pause the video. And here's your steps that can help you out if you get stuck. And then we'll check in a minute. Okay, so hopefully you've had enough time to do the problem. Step 1 is to estimate. We have 1 and 200ths. That's really close to 1. We have 2 and 6/10. It's kind of really close to being in the middle between 2 and 3, but because this is a 6, we're going to bump it up to 3. So we know our answer has to be pretty close to 3. What's the second step? We're going to count the places after the decimal. 1, 2, 3. I'm going to write that over here to remember that I have to have 3 digits after the decimal. Step 4 is to solve without the decimal. I'm going to take them out, and then I'm going to solve it. If I use my area model, do that one first, I would have 100 plus 0 plus 2. And then I would have 20 plus 6. In this case, I would end up with 3 zeros after the 2. A 0 would be here, and actually a 0 would be here too. And then I'd have 40. 100 times 6 is 600, and we have 12. When we add all these up, we'd get 2,640, 2,640 plus 12. That would give us 2,652. But remember, we have to find a place to put the decimal. Where would we put the decimal that would be closest to 3? Hopefully you remember that we needed 3 spaces after the decimal, and we put it here. Is 2 and 6/10, or excuse me, 2 and 652 thousandths close to 3? It is. That's the answer that makes the most sense. You could, of course, solve this with the algorithm too. All right, thank you for watching. I hope that this helps you solve things with decimals.